So now we're going to try and do limits using algebra. So evaluating limits using algebraic manipulation. So let's get right into an example. I want to find the limit as x approaches -1 of x plus 1 over x squared plus 3x plus, am I doing this right, 2. Well, let's just roll with it, see what we get. Alright, so the first step you always do when you're evaluating limits is to try direct substitution. Because sometimes you don't get an indeterminate form, which is 0 over 0. Okay, so indeterminate form. Zero over 0. There are other types of indeterminate forms that I'll probably get on into later, but much later, not in the near future. You just need to know that 0 over 0 is a possible type of indeterminate form, and we'll get into more types of indeterminate forms once we do L'Hopital's rule, which I'm going to do later, like a lot later. So, yeah, try direct substitution because sometimes you just get a limit right away and boom, that's your answer. Why does that work? It's because even though we're technically not, the limit technically doesn't mean that we're calculating the exact function. If the function is continuous and has no holes, it's not going to have any of those jumps or places where it's undefined. So we can just directly substitute and we won't run into any problems. But if you do get an indeterminate form, like if you plug in -1 here, you're going to get -1 plus 1 is 0. You're going to get 1 minus 3 plus 2, which is also 0. So this is going to equal 0 over 0. So what you do is, if you get an indeterminate form, is try factoring and canceling terms. So here what we do is, well, x squared plus 3x plus 2, that's about as basic of a factoring trinomial that you can factor. So this is going to equal limit as x approaches -1 of x plus 1 over x plus 1 times x plus 2. So the x plus 1's cancel, and this equals limit as x is equal to -1 of, not equals, approaches -1, my bad, of 1 over x plus 2. Okay, and now we go back and try and do 1 again. We try direct substitution. So when we do put in direct substitution, we get 1 over -1 plus 2. That's 1 over 1, which is 1. So we have our answer. So usually, if you have a trinomial or something that's factorable, you're going to be able to do it. And third, if that doesn't work, if it doesn't look like it can be anything that factors, try multiplying by conjugates. And the ultimate last step would be to use L'Hopital's rule, which works on anything, almost anything. But we're not going to go over that yet. So we're going to do an example by multiplying by conjugates now. So here's a problem that I copied down, and it uses multiplying by conjugates. So this is the limit as x approaches 25 of 5 minus rad x over 25 minus x. And if you plug in 25 here, you'll see that we get 0 over 0. So what do? Well, we're going to multiply both sides by 5 plus rad x, which is the conjugate of 5 minus rad x. And what do we get? We're going to get limit of x approaches 20. Limit as x approaches 25 of 5 minus rad x times 5 plus rad x over 25 minus x times 5 plus rad x. So I'm not going to evaluate the denominator yet, and you'll see why. So this is equal to, FOIL this out, we get 25 in the numerator, plus 5 rad x, minus 5 rad x, so those two cancel out, so I'm not going to write them down, minus x. The denominator stays 25 minus x times 5 plus rad x. So as you can see, the 25 minus x is cancel out, which is why I didn't touch it. So this equals 1 over 5 plus rad 25. If we direct substitute 25, we get 1 over 5 plus 5, which is 1 over 10. So those are the two main ways you're going to see limits being evaluated using algebraic manipulation. You're either going to factor, which is most of the time, or if they give you a square root like that, you're probably going to have to do some conjugate stuff.